Side of this, we're just going to re-practice our Pythagorean theorem. Please go ahead and close the computers. So what is our Pythagorean theorem? I'm just going to write it up here next to name. Who remembers that from last time? What is your Pythagorean theorem? You've heard it before. What is the Pythagorean theorem? I'm going to wait you out because I know you know it. Would anyone want to find their notes from last time and find what the Pythagorean theorem is? What is the Pythagorean theorem? There we go. Thank you. A squared plus B squared equals C squared. And the only really important thing to remember is C has to be across from what? The right angle. Okay, good. We got there. It took a minute, but we arrived. All right. So for this first one, what you need to do is draw in the rest of your triangle. So go ahead and draw in the rest of your right triangle. This is our right angle. And across from that, we're going to put C. That is always the first step. Find your right angle. C goes across from it. A and B don't really matter. So you can put those wherever you want. I'm going to call this A and this B. But that doesn't really matter. As long as C is in the right place, then you're good. So what we're going to have to do is count the little boxes along the sides to find A and B. We've done this before, and I told you to just put little dots on them. But can you count with me? Look, 1, 2, 3, 4, 5, 6, 7, 8. Do you see how I counted to 8 there? Along the side? A is 8. Could you guys count and find B for me? Put your little dots on it. How long is side B? Good job, 6. B is 6. And you're simply going to plug those numbers into your Pythagorean theorem. It's going to be 8 squared plus what? Good job. 6 squared equals C squared. I'm going to kind of be your calculator for the purposes of this. 8 squared, 8 times 8 is 64. Or does anyone know 6 squared? I'll throw it out there. That's 4 squared. But that is a perfect square, so that's good. No one else said anything. It's 30-something. 36. Good job. We'll C squared. If you add those together, you get 100. And then you have one more step. How do you get rid of a squared? Square root. Good job. Your square root of 100 is 10. You would just type in Desmos, square root of 100. All right? Let's try another one. You're going to find your right angle. Across from that is C. That's always the first thing you do. Find your right angle. Across from that is C. The other ones, A and B, you can put wherever you want. And then you're just going to plug it into your Pythagorean theorem. It'll be 8 squared plus what? Perfect. 13 squared. Oh, equals. Sorry, need my white out here. I was about ready to write another plus. Equals C squared. So 8 squared is 64. 13 squared is 169. Again, I'm kind of just being your calculator here for that. If you add those together, let me see, I don't want to do that wrong in my head. 64 plus 169 is 233. I just typed it into Desmos. And then what's your last step? How do you get rid of a squared? Square root. Now 233 is not going to work, so you're just going to leave it square root of 233. I guess you could type that in and get a decimal answer if you really wanted to, but we're going to just leave it alone. Coming back to us from 2 days ago at all? Sort of. Let's try another one. Here's your right angle. C goes across from it. So C is 9. It doesn't really matter which one of these is A and which one's B. So just throw those on. So put everything into your Pythagorean theorem. A squared plus B squared equals C squared. How's it going to start? What's A? So it'd be 7 squared plus, now you could say B squared or you could say X squared. It's really not going to make a difference, however you want to write it. Equals what? What's going to go on the other side? 9 squared. Perfect. And then we're just going to figure out what that is. I'm going to just sort of be your calculator. Or does anyone know 7 squared? 7 times 7? And throw it out there. See if anyone knows it. It's 40 something. 49. Good job. 49 plus x squared equals 9 squared. 9 times 9 is 81. Now, how do you undo plus? We want to cancel out plus. So we're going to subtract. Good. We're going to subtract 49. I'm going to have to come over here. X squared equals, all right, 81 minus 49. I don't want to mess it up in my head, so I'm going to just type it in. 81 minus 49. I got 32. Bless you. And then to get rid of the squared, you're going to do what? Square root. Perfect. Now 32 is one of those ones that's going to split. We talked about this last time. You're going to draw 2 little houses. And again, I'm going to kind of be your calculator for this. You have to come up with 2 numbers that multiply together to be 32, but one of them has to be something that you could actually square root. Okay? And it's going to end up being 16 times 2. I'm just kind of being your calculator there. If you had Desmos, I think you could probably figure it out. But 16 times 2 gives you 32. Bless you. And then the whole point of that is that the first one's going to work. What is your square root of 16? And when I ask that, what I mean is what number, if you times it by itself, is going to give you 16? 4. Good job. So 4 square root of 2. So we're building our number sense there. Nice job. We're just going to do 4 and 5. We'll skip 6 and 7 because those are kind of, that's a lot and they're kind of complicated. We're just going to try a couple more. All right, for number 4, do you see these 2 little tick marks there? What does that mean? If you have a tick mark here and a tick mark here, that means these sides are what? Congruent. Good vocabulary. So if this is 24, this side is also 24. And do you see how the side at the bottom is 22? Well, we cut it in half. So what is each part of this going to be? If you take 22 and cut it in half, think like you have $22 and you share with a friend. They're each going to be 11. Good job. Let me find a highlighter here. Let me see if I have a highlighter. We're going to just look at half of this and do our Pythagorean theorem. Which side is C? Across from the right angle. Which side is C? The 24 is going to be C. A and B don't really matter. So I'm going to make this A and this B. And then you're just going to plug it into your theorem. A squared, which you could write A squared or you could write X squared. It really doesn't matter. Plus, and then what's B? Oh, close. It's that side, but we just want this half of it. Oh, 11 squared. Perfect. Equals, and then what's C? What we label as C? 24 squared. Good job. So we just needed like half of that triangle. It's kind of 2 triangles in one. All right, then we're just going to work this out. I'm going to kind of be your calculator. 11 squared is 121. I don't know 24 squared off the top of my head, so I'm going to type that in. It is 576. And then what would be your next step? You want to cancel out this plus. So we're going to subtract 121 I'm going to come over here. That's going to give us x squared equals 576 minus 121. I'm just going to type that into Desmos. I got 455. Again, I'm just kind of being your calculator here. And then what is your last step? How do you get rid of a squared? Square root. 455 is not going to work out, so you're just going to leave it. Square root of 455. Sometimes it's like that. You just leave it alone. And we're going to try one more of these. And then everybody's being quiet and nice, so I'll give you a little brain break. The problem with number 5 is, do you see a triangle? Is there a triangle in there? No. Okay, so we're going to have to create one. So what we're going to do is fill in this line here and put our right angle, and now we have a triangle. Do you see this triangle here? That's what we want to look at. So this side is going to be x. It matches up with this one. The other side is a little more tricky, so follow me here. This whole distance is 18. This little piece of it is 5. So the whole thing is 18. This little bit of it is 5. How could I figure out what just this part is then? The whole thing's 18. We're going to subtract them. So 18 minus 5 is going to give you 13. So the whole thing was 18. We subtracted off that little bit that was 5. So you actually don't need any of this. This is all extra. We don't need that. So we're going to label A, B, and C. What is C in this case? 16. Good. A is 13. B is x. So you're going to put it into your Pythagorean theorem. A is 13. So we're going to say 13 squared plus what squared? What, x squared, good. Or you could say b squared, either way, equals 16 squared. C is 16. All right? Now, put that in the calculator. 13 squared, I think that's 169. We did that one earlier. Yeah, 13 squared is 169. I do not know 16 squared. I'm going to type that in. I should probably memorize a whole bunch more of these. 16 squared is 256. We got 2 more steps. What's the next one? We want to get the x squared by itself. So what are we going to have to do? That'll be our last step. Subtract. Good job. We're going to subtract 169. That's going to be x squared equals, let me type that in, 256 minus 169 is 87. And then that last step is to square root. So your answer is square root of 87. Flip over. So a triangle has sides of 5, 8, and 11. Is it a right triangle? So we're going to test and see if the Pythagorean theorem works or not. So we're still using Pythagorean theorem, but it's kind of like a yes-no question. Does it work or not? Okay. And again, we need to make a connection between what I'm saying to you right now, and then you're going to have a classwork on it. Now, C has to be the largest number. So which one of these is going to be C? Which one is the biggest? 11, all right? So that's C. The other two doesn't really matter, right? So we're going to have 5 squared plus 8 squared equals 11 squared. Maybe. I don't know. We're going to see if it's true or not. Just going to throw the question out there because 5 is a little number. What is 5 squared? 5 times 5. What's that going to give us? Just 25. Good job. 8 squared is 64. And then 11 squared is 121. So we're just going to see if that's true or not. Now, if you add these together, you're going to get 89. So does 89 equal 121? Is it true? No. Obviously, it did not work. Do you need a bathroom pass? Right, but it still has to go in the system. You guys see how they're not equal, right? Like how it didn't come out the same? Okay, cool. alone in the room. All right, so whenever we do our Pythagorean theorem converse, and if you take a if-then statement and flip it around, that just means the converse. Simply means we're going to do it backwards. Here's the only thing you have to really get with this. The c squared is going to come first instead of at the end. It's just going to be in the backwards order, okay? If you have less than, it's going to be an acute triangle. And what does acute mean? Let's just review what acute means. Less than 90. So that's why the less than kind of makes sense there. And if it's greater than, it's going to be obtuse, which means more than 90. So it makes sense. Less than is acute, greater than is obtuse. All right. So let's test this one. C has to be the biggest number. So 4, 5, or 6, which one's the biggest? 6. Okay, so C is 6, and it doesn't really matter about the other two. Again, C has to come first when you do this. All right, that's the only thing about this converse is it's the other way around. And I'm still seeing computers open. Can we please close those? So I'm going to put the 6 squared first. Here's the other thing. I don't know if it's equal or not. So don't put an equal sign. Instead, what I suggest you put is a little box. I don't know what's going to go there. So just put a little space. All right? And then you're going to put the other two, the a squared plus b squared. So 4 squared plus 5 squared. And we're just going to work it out and see what we get. It's just, hey, I don't know how this is going to turn out. So let's see. 6 squared is 36. What's 4 squared going to give you? 4 times 4. And you do 4 times 4. Can you please close that computer? Be 16. And then 5 squared is 25. So we still have 36 on this side. We're going to add those together. 25 plus 16 is going to give us 41. So here's the $1 million question. Is 36 bigger or smaller than 41? What do you think? Smaller, right? Less than. Less than means acute. Less means acute. Bigger means obtuse. Right? So let's try it again. Here we have 4, 6, and 8. 8 is going to have to be C. And then the 4 and the 6 are going to be A and B. Again, C has to come first. That's the only thing with this. C has to be first. So we're going to put the 8 squared first and just leave a blank because I don't know what it's going to come out to be. So I'm not sure. Just leave a blank. And then you're going to put the other ones, 4 squared plus 6 squared. And then you just see what you get. 8 squared is 64. 4 squared is 16. What's 6 squared? Do we remember that one? We did that one earlier. 6 times 6. 36. Good. I think I heard somebody whisper it over there. All right. So this side is still 64. If we add those together, we're going to get 52. So here's the question. Is 64 bigger or smaller than 52? Bigger. Bigger means obtuse. So you're testing to see how it works out. So let's just try a few of them. Okay, let's try a couple more. So looking at this first one, we have 40, 41, and 9. What is the biggest number out of those? That's the first thing you have to identify is what's C. So what's the biggest number out of those three? 41 is the biggest. That has to be C. And then the other ones are A and B. But it doesn't matter which is which, right? But we're going to put C first. So it'll be 41 squared. Leave a blank because I don't know what it's going to be. And then what will we have on the other side? And check who's been paying attention. Set it up the same as the other ones. What will we have on the other side of that little box? 40. What does it need with it? Squared. Good. Plus 9 squared. Perfect. All right, I don't know 41 squared. I'm going to type that in my Desmos real quick. 41 squared is 1,681. 40 squared is 1,600. And 9 squared is 81. So if you add those together, you get 1,681. So what do you notice? What happened? This side is 1681, and this side is also 1681. So what do you notice? They're equal. So if one isn't bigger than the other, it is a right triangle. The Pythagorean theorem worked. That's kind of like a yes or no. That one worked. All right, let's try another one. You have to figure out what is C first. Out of 10, 20, and 15, what's the biggest number? 20. Good job. That's C. Here's A, here's B. C has to come first when you do this backwards. So it's going to be 20 squared, leave a blank, and then what will go on the other side? 15 squared, good, plus 10 squared. Nice. And we're just going to see how it works out. So 20 squared is 400. Again, I'm just kind of being your calculator. 15 squared is 225. Does anyone know 10 squared? 10 times 10? 100. And then we're going to see how this worked out. If you add those together, you're going to get 325. So here's the $1 million question. Is 400 bigger or smaller than 325? Bigger. What does bigger mean? Acute or obtuse? Obtuse. Bigger means obtuse. Well, maybe just try one more here. All right, figure out what is C first. You have 12, 11, and 14. Which one's C? 14. It has to be the biggest one. All right, and then the other ones are A and B. C has to come first. So 14 squared, leave a blank, and then the other side is 12 squared plus 11 squared. I'm just going to see how it works out. I do not know 14 squared. That is not one that I have memorized. So let's see. 14 squared is 196. 12 squared, I know that one is 144. And 11 squared is 121. So let's see what we get. If we add those together, I got 265. So here's the question. Is 196 bigger or smaller than 265? Smaller, and smaller means acute. So smaller is acute, bigger is obtuse. We did one of each, so I think that's plenty good enough.